Hello, thank you everyone to be here to attend to my lecture dedicated to a case of use of our CMS Creator hybrid 3D printing and milling machine. The agenda will be an overview, a profile of us, and the explanation of the reasons of the building of technology like that for us. Then why additive manufacturing in general and for a big machine builder, what CMS Creator is, and the case of use of life-size mold, and conclusions. The machine is not important. It's important the customer needs. This is the motto of our founder, Mr. Pietro Accetti. Now, we are belonging to a group with more than 700 million of turnover, more than 4,000 people, and spending around 7% of the turnover in research and development. Inside of the group, we are manufacturing machines, technologies for advanced material, that is composite, aluminum, advanced other materials, but also plastic, stone, glass, and also metal processing. This is an overview of our range of machine tools. Machine tools, 5-axis, 3-axis, 5-axis machine tools with, for vertical, horizontal milling, made with different geometries. And finally, CMS Creator, the latest creation by CMS. Our application sectors are the typical application sectors of composite, that is aerospace, marine, automotive, railways. We can say we have been partner of important brands like Oracle USA Team, but also Boeing, but also Artemis in America's Cup. And in this slide, you can see an overview of the technology we can offer to our customers. The first one, the number one, will be the focus of the lecture. That is UHF table. The latest one is Creator. In the slide, you can see some pictures of the latest exhibition for Next in Frankfurt, where we have started to exhibit the Creator. A lot of people was interested because it was the largest 3D printer in the world at the moment. Why does a machine tool builder start to deal with additive manufacturing? The reason is additive manufacturing is a young industry, but with a very, very high growth rate. And the high growth rate is due to the advantages that the technology is able to grant to the user. Technologies in terms of material savings, energy savings, time savings. You can feel in this slide, at the first sight, the youngness of the technology. The blue arrow are related to the first industrial patents related to additive manufacturing, 84, 88. But the gray arrows are related to milestones of other industry, like 1913 automotive industry, the first manufacturing line by Ford T, of the Ford T. 63 is a milestone for plastic industry, the Nobel Prize to Giulio Natta. 81 It is for our composite manufacturer and working on composite for machine tool, the milestone for composite. That is the first race won by a car having a Formula One car having the monocoque made of carbon fiber. But our specific declination of additive manufacturing, that is large format additive manufacturing, is young enough, that is 2014, December 2014, the first large format additive manufacturing. And you can see in this slide the growth rate of the industry. It is not a provisional, they are historical dates. Since 2009, the growth rate was 9%, not bad. But in the decade from 2009 to 2019, the growth rate ramped up to 28%. Why? Because before, additive was used for prototyping, and after, in this decade, start to be used in production. Production for aerospace, for automotive, for general industry, for toolings, 19% of the turnover. And the sector I mentioned before was the 61% of the growth of the sector in this decade. This is Creator. What Creator is? A CMS machining center, equipped also with an extruder, an extrusion head, I may say, to get the screw extrusion additive manufacturing together with the standard milling. This project has been developed in cooperation with Fraunhofer. The Fraunhofer, based in Chemnitz, specialized for technologies for the plastic forming and for machine tools. This is the acronym, IWU. It can be used to manufacture toolings for composite, machining jigs, lamination master, direct molds, but also other applications in the context of epoxy overall replacement, and also in the context of FDM replacement, taking advantage of the dimension of the 3D printing, the 3D printed part possible with this technology. The key buyer benefit of our solution, high flexibility, that is the full integration between a machine tool and a 3D printing machine, and the possibility of using it with different materials and in different ways. Material saving, due to the fact that the additive manufacturing, when compared to the standard subtractive technologies, is proper to manufacture hollow parts, when the subtractive technologies are machining solid parts. And then it is a sustainable solution, but for the material saving, up to 5 times less material than traditional technologies, but also less time, less energy, and the possibility to manufacture parts that current FDM technologies are not able to do in just monolithic way, but they have to manufacture them in several subparts, less subparts. In this diagram, you can see a comparison between the current manufacturing 3D printing machine in the left side, the blue dots, and the Creator, the green dots, Kreator Ares in 2 ways, that is with vertical 3D printing and 45 degrees 3D printing. And the light red shaded area is the coverage of this range of the strokes of the CMS solutions. If you consider that the area is in logarithmic scale and the height is in linear scale, you can see that we have the possibility of multiplying for several times the possibility of the additive manufacturing of today with the large format additive manufacturing. Important feature of our solution is the quality of the 3D printed material. We started with a cooperation with Research and Development Institute to get the best quality, and the best quality is obtained by the classical design of the extruder. That is, the design of the extruder is similar to the one of the extruder for extrusion plants and for injection presses, when the melting of the granulate is obtained by friction in the center of the extruder and not by heating by resistance. The material flow is 10 kilogram per hour. High quality material means what is called vacuum integrity. That is, there is no possibility for the vacuum or for the air to pass a wall, 3D printed wall, with this system. There is no voids inside. It's not possible to go to warranty this 100%, but there is no possibility to make a crossing the vacuum or the air from one side and another side of a wall. Materials. We are open to a wide range of materials, including also material proposed by the customer. Every material needs to be certified, I can say, because we have to define the extrusion parameters proper for these materials. But basically, we are using material for room temperature usage with low TG, like PA6, for instance, and also material for intermediate temperature in autoclave, proper for automotive application, 120 to 130 degrees curing, and also material for high temperature in autoclave, 170, 180 degrees. The first is polycarbonate, and in our booth we have a couple of samples 3D printed and milled made of polycarbonate, but we have already printed parts in polyethylamide, also popular as Ultem. What does it mean, integration between a machine tool and a large format 3D printer? First, we are the only solution having the electrospindle of a machine tool that is moving also the screw of the extruder. And the change between the mechanical tool and the extruder and vice versa is fully automatic, as you can see in the GIF image in the slide. The second point is the material feeding is completely integrated in the robotic chain of the machines. There are additional robotic chains that are carrying the hoses for the granulates, the signal, the power for the management of the extruder. Another important point is the refilling of the material is off the machine with the dryer of the material. Every material, plastic material, thermoplastic used for 3D printing needs to be dried before. After the first drying cycle, a continuous cycle may start and the material can be added off the machine when the machine is working 3D printing. Some projects, thanks to Bercella, that I see in the first line, we had the possibility to take part with our creator to the Resto Mode Maserati project, promoted by Trussardi. With Creator, direct molds for carbon fiber parts that have replaced steel parts in the Maserati, resto mold Maserati, and lamination master. In the picture, in the low right picture, you can see. Another application, this is a direct mold for the manufacturing of spare part of a very old and out of production Mitsubishi that took part to the Dakar Classic. We are also working on a larger extruder, up to 100 kilogram per hour, even if our approach is to use less material than what you can see on the market and more printing speed to allow the customer to save more material than other. We have the need to enlarge also for some application the dimension and also the quantity of the extruded material. It's not available yet, but we are working on it. Finally, the focus of my lecture, that is the UHF table and the lamination master or the direct mold for the calibrator of the UHF table. UHF stands for Universal Holding Fixture. In the aerospace, when you have to manufacture parts of cabin, you need 3D shaped toolings to hold the part. You can think, okay, but the center of the aircraft have only one radius, right? But the nose cone and the tail sections are continuously changing, and this forces to have a lot of jigs to hold the part. This implies a lot of stock, a lot of wasted time for managing this change of toolings. Universal Holding Fixture Table is an intelligent tooling made of dozen, up to 100 suction cups, each one equipped by an independent numerical control that can orient it to every position and to allow to hold any shape. It is crucial, the calibration of a tool like that. The set point of a numerically controlled machine is a crucial point. And the way to make the set point of a complex system like that is to manufacture a glass fiber sheet in order to reply a well-known surface and in order to try to manufacture it, to hold it first, and to manufacture it first in our facility to check the machine, to adjust the machine, and then after the installation, during the installation at the customer premises, to check with the customer if the machine is the same as we have tested in our facilities. To laminate this sheet, we had the idea to manufacture a direct mold by Creator with a 45 degrees 3D printing. You can see the 3D printing stage, the milling stage. Then we gave the mold to a customer of ours because we are not manufacturer of composite part for the lamination and the curing. And this is the result. It's a part with a 2 meter per, around 2 meter, 700 millimeter, 220 kilogram, with 55 hours of 3D printing and not so left 11 hours of milling time. 3D printing at 14 meters per minute, high-speed 3D printing, we can say. But the most important data is 83 3.4% of saving material saving, when compared to the traditional technology. That is hollow part compared to solid part. Okay, we have seen high flexibility, material saving, sustainability of the solution has been confirmed for what I have explained to you. Our recommendation is, please challenge our technology. We may sign a mutual non-disclosure agreement to be more free in exchanging information. And then, for free, we study the feasibility on the paper, on the computer, the feasibility and the data for the material consumption and so on. You know, it is designed for additive manufacturing. It is a practice common in additive manufacturing. That is, you have to redesign a part to allow the additive manufacturing of this part. And after having checked feasibility and the competitiveness projection on data we have on our computer, we, together with the customer, with the approval of the customer, we start to print this part and to mill it. So, if all can satisfy, we can think about the machine, but not before. I recommend customer, please don't give us the most complicated part of your life, neither the simplest one. An intermediate part is good for this test, just to understand the competitiveness of this technology when applied to a real customer part. I think there is not so much time, I think 1 minute for questions, but if you have some question, I am here to answer, to try to answer. And thank you again. Thank you very much. Okay. I'm sorry, but I have not eyeglasses because all eyeglasses or mask, and I cannot see people asking something. So I thank you again, and I left the stage for the next speaker. Thank you.